structural design of facades. From where do we start? I'm meeting now with Miriam to learn about this. So I'm doing this structural design of our facade, as you know, and now I'm at the point where I really need to quantify the loads and resistance of the facade components to check they are designed safely enough to sustain, withstand the loads and be therefore creating a safe layer. No? But I'm getting a bit confused between design values and characteristic values. So I was wondering if we could recap together so then we can apply very well these principles to our design.
Yes, of course we can. So I can explain you the concept of design with the Eurocode 0, which is valid for Europe. And yes, in fact, we have two limit states which have to be proven. This is the ultimate limit state and the serviceability limit state. And in both cases, we need to show that the design value of a load or an effect of a load is smaller than the design value of a resistance. And design values are modified characteristic values, which means that we have a characteristic value and partial safety factors. So when we have a characteristic value of a load, we increase this load by multiplying the characteristic value with the partial safety factor. And on the other hand, we have our resistance, and the characteristic resistance value is decreased by dividing it with the partial safety factor.
So let's have a deeper look on this. There is a distribution function of potential loads acting on the facade, and on the other end, I don't have one value for the resistance, but I have a distribution of values. And this is effectively what is describing the loads and the resistance of the structural design part. So in terms, what you're saying is that, first of all, I'm gonna be looking at the characteristic value of the load, which is when I see this red curve, which represents the density function of the loads, the characteristic value, can you repeat what is it?
Yes, the characteristic value is a quantile value between 50% and 89% for the load case or the effect of loads.
98.
98.
Sorry, yes.
98%. So, and this means that the loads are with a probability of 50 to 98% in the range of these values.
And this is not enough to be safe. What the Eurocode prescribes us to do in addition to this. So we already are in the right part of the curve, so which is the higher potential values. But on the top of this, we're going to apply safety factors, which are going to even increase further.
Yes. Yes. We use those safety factors to consider uncertainties in the loads, in the effect of loads, and also in the resistance.
And so the design value in terms of loads becomes this final value that I compute by multiplying by the safety factors. And this is one value, the one that is going to represent in a safe way potential loads on our facade. And then you were saying that we do the same for the resistance. But on the other end, here we're going to be at the left part of the curve, so in the range of the lower potential resistance values to be safe. And on the top of this, we're going to multiply them by safety factors to even decrease these values of resistance to consider potential uncertainties.
Yes, exactly. So on the resistance side, we often use the 5% quantile value, which means that only 5% have a lower value than this characteristic value. And in addition, we have again the partial safety factor, as you said. Yes. However, we don't have a 100% reliability. So there is always a failure probability. And when you are looking at these curves, the failure probability is the area where the two bell shapes are overlapping.
Okay, so effectively where the two curves overlap, it means that the resistance becomes potentially lower than the load that is acting, which means that then there is a probability that the structure fails. And of course, for safety, what we are trying to do is to pull apart this curve as much as possible, but in reasonable ways, because we don't want to over-design. So effectively, the Eurocode or other standards, depending on the approach they follow, may prescribe us to how big can be this area of overlapping because of safety.
Yes.
Okay, so now I will apply this to the design of the facade we're doing, which means that I'm gonna look at the loads that are acting on the facade, wind, self-weight, etc. And I'm gonna multiply them with the safety factors and identify then the design value. And I will do the same for the resistance. And then what I need to do is to check that the size of the components, the material properties of the components are sufficiently good to provide a resistance that matches the design value of the resistance, and that this resistance, of course, is higher than the design value of the load. Correct?
Yes.
Okay, we will do this then. Hands on the calculations.
Enjoy.